Okay, it now, as far as I can tell, being 9:30 and a decent number of you being prompt, thank you for coming. This is the SFC working group at IETF 100. I'm Joel Halpern, one of your two working group chairs. Jim Gishard is the other one. He got called away at the last minute and will be joining us in about a half hour, but he'll be here as promptly as possible. Tal Mizrahi is our working group secretary. Tal, can you come get the blue sheets and circulate those? Please do sign into the blue sheet. This is the note well. You've probably already seen it more times than you like, and you will see it a lot more times. Yes, it's procedure, but it's important. You have to abide by this. It's what we need in order to function as a community. So please remember we have rules. You're making your material available. You will disclose your IPR in a timely fashion. All of the other things that are described in the various BCPs. Please abide by them, understand them. If you're not familiar with them, go look at the BCPs. Thank you. I'll be going through the agenda so people know what order things will be coming up in. The ROF grouping will be having just over an hour on OAM material. We'll then be talking about some forwarding mechanisms proposals that people have sent in, and a group of topics that I can only describe as interesting but miscellaneous. They're useful things, but they're a general category. And then we're scheduled to close. If we are ahead of schedule, as I said on the mailing list, I will present the initial thoughts, and all they are is initial thoughts by your chairs and ADs to get things started for what might go in rechartering, because we've completed NSH. Congratulations to everybody. It is in the hands of the RFC editor. It will be published. And my thanks to all of the authors, and particularly to Carlos, who took the pen during a very difficult time and carried the work forward. So congratulations to everybody, and thank you. And that's why we'll be doing rechartering. So to look at the agenda in more detail, the OAM material, you can see there's a list of them. Greg and Ting will be presenting that material in about 65 minutes, and I'll be going through the slides. 2 notes to presenters. Please stand in the pink box. There is a camera, it's focused there. So if you're there, people can see you. And I am your clicker. Tell me when to advance pages, because my laptop and the nice remote control do not get along. So I will advance slides. I will advance to the next presentation if there are several related. Just work with me on it. We'll get through things in a timely fashion. So we're going to talk about multi-layer OAM, some different OAM behavioral issues, performance measurement, and in situ OAM, all in the OAM block. So the 65 minutes has to include time for Frank. So Greg and Ting, you have about 50 minutes for yours. We'll then do about 30 minutes on forwarding mechanisms, MPLS-based forwarding plane from Adrian, and a unified presentation using unified, I wish this thing didn't display that bar, but I can't make it go away. There it is, using unified source routing instructions from Xiaozhu. We'll then have, under the miscellaneous category, some discussion of the timestamp MD1 proposal, alternative handling of dynamic chaining and service indirection, and optimized service function chaining. And then we'll close, and as I said, if time permits, we will do charter discussion, because I'd love to get some discussion in the room of what we have. So with that, Greg, I think you're the first one.
Thank you. Good morning, everyone. Formally, this is update to the document that we work on, but at the same time, there are a lot of new content, and one of the main contents is that you can notice that we scope on active OEM. and active OEM in the interpretation of RFC 7799 that we only look at the use of specifically constructed test packet that being injected in the network, in this case in SFC network, to monitor or do measurements. Next slide, please. SFC NSH document defines O-bit and says that if this is OEM packet, then O-bit it has to be set. But we believe that it doesn't sufficiently address the scenario of active OEM. So our proposal is to define OEM as a protocol type, and in combination with O-bit set to identify the active OEM packet.
Could you move a little closer to the mic?
Okay, that's better?
That's much
Sorry,
better.
thank
Thank
you.
you.
Thank you. Thank you for feedback. I can't hear myself over there. So in combination with O-bit set as defined in SFC NSH document, OEM protocol in the next protocol field identifies active OEM packet. So this is a proposal 1. Proposal 2 is the question of how to demultiplex various active OEM protocols, because we can imagine that we'll have a set of active OEM protocols in SFC to monitor continuity, to do on-demand troubleshooting and failure localization. It's a functionality like ping and trace route, and to do performance measurement. So with the multiplicity of OEM protocols, we want to demultiplex that. Usually in IP networks and in MPLS, we use the same method, is to use well-known UDP port. But that requires UDP encapsulation. So the question here is whether we continue this use of IP UDP header-based demultiplexing, or we introduce SFC OEM header, which will have message type to differentiate demultiplex active SFC OEM protocol. In our opinion, the tax of IP UDP header is significant comparing to the size of SFC OEM control message, so that use of header is justified. Yes, feel free to interrupt and ask questions.
Kyle Rose, Sandvine. There's also an NSH ether type. So if you're communicating NSH over Ethernet, then you can't really do this if it has a UDP header.
No, I can inside NSH to have.
Oh, sorry. I thought you were saying you would encapsulate this in UDP.
No.
Never mind. Ignore me.
No. Yes, I think I jumped over because I assumed. Sorry, and thank you for pointing it. No, UDP encapsulation is under NSH. That's how we do it in MPLS. So destination address, we use 127/8 and comparable address in IPv6, so that it's a Martian address. And then inside this encapsulation, we use UDP port, well-known UDP port. And this is well-known method that what we use in LSP ping and what we use in BFD over MPLS LSP to use IP encapsulation, and we use this destination port number as demultiplexing for the active OEM protocol. So that's one of the options for SFC. But again, we need to consider the tax of extra encapsulation. Next slide, please. Next, what we added in this update, in this new version, is echo request reply. The most basic and widely used and very useful, as history tells us, and we learn ourselves, method of, well, doing some basic troubleshooting. Again, if we look at it, it's very similar to MPLS LSP ping with some remove. So we remove mandatory timestamp. There was a discussion saying, okay, do we really need a timestamp that can do round trip delay? Because if we do SFC, whatever SFC topology is, or SFP topology is, it's a unidirectional. Yes, we can return this value of measured time between classifier and egress of SFC to the sender or to somebody else, because again, there might be some extensions that we are planning to be able to do that. But the question is that what would be the value of measuring this return path, which would probably be out of band, out of SFP. So that is something that we open to discussion, whether to have any measurement, time measurement based on echo request reply.
Kyle LaRose, I know there's a draft out there which talks about ways of building the reverse path algorithmically.
Yes, there is a.
So we could potentially, in that case, cases that deploy those algorithms could do bidirectional communication.
Very good, thank you. What we thought of, because if we can go back, so there are global flags. An idea of the global flags that we can indicate optional fields that are extension of the request, and timestamp might be one of them.
Is that what the TLVs are at the bottom?
Yes.
Okay, thanks.
Okay, so I mentioned that demultiplexing and the reply. That reply most likely go out of band, out of SFP. And that will use, again, most likely, IP-UDP encapsulation in IP network. So to demultiplex reply, we think that we need well-known port. And the document has a request for IANA to assign UDP port for echo reply. But that's assuming that we don't need UDP port for echo request, because in NSH encapsulation, our assumption and our proposal is not to use IP-UDP encapsulation overhead, but to use SFC OEM header. Next slide, please. So we're open for comments. We have a lot of assumptions we've done with this format, and we would like to hear your comments, feedback, and participation.
Kyle LaRose, one more general comment. You request allocation of a next type for OAM.
Yes.
I think Frank's document also requests a next type of IOAM. And I'm wondering if they should be the same or if we should be making this explicitly active OAM.
Good question. I think that that should be the same, different, because what we, again, more specifically, we request active OAM type.
Okay.
Yes, Adrian. The same can be done with the next protocol none in TOV. So the active OAM can be realized, implemented by using metadata. And that's another thing that we would like to discuss, whether use the method that proposed by Adrian in next protocol none, but then how we identify that this is, so basically then we need to have a TOV and register of TOVs, and that's how we demultiplex different OEM protocols.
Yeah, thanks.
Adrian Farrell, thanks, Greg. This is a really good walk around the block, and I think it's helpful for us to get the options on the table. But of course, options are evil, and it would be really nice if we can take this and start throwing out some of the options, so that we end up with probably one way of doing and encapsulating OEM, whichever it is, and I'm sure lots of people have different favorites, but putting them all on the table to start with is the right thing to do.
Thank you, Adrian. Actually, that's our intention, to narrow everything to one thing that we all agree and do it once, because options, it's a nightmare for implementers. Yes.
Thank you for that.
And that's a killer for implementers. Okay, so I think that, I hope that you will read the document, and we'll probably discuss it in the list. And as always, yes, we would like working group chairs and the working group to consider adoption.
Next. Again, adjust the mic and talk very close to it.
Okay. Can you?
Move closer.
Good morning, everyone. I'm Ting, and the following two slides will be based on the presentation from Greg just now. The first slide is about SFC path consistency OEM, and we call consistency OEM to be COM. Next. This is the basic theory of COM. COM is to check the SFP consistency. Every SFF received a COM request. It have two actions. One is to forward the COM request to its next hop. Another action is to reply the COM with the SF with the service function information in the reply message. Once clearing all the COM reply message, the whole SFC path will be confirmed. Next.
Quick question on that. If a single SFF is supporting multiple service functions in the chain in sequence, not spirals and other weird cases, would it send one reply, or would it send several separate replies to reflect the multiple service functions it's supporting?
Wow.
Suppose SFF1 had SF1 and SF2.
Okay.
Would it send one reply or two?
I think it should send two SF service function. I mean the two service function in the same path.
Mm-hmm.
A similar question. What if there's multiple choices for a service function, right? So you're doing load balancing or something like that. Do you represent that load balancing group as a single service function and send one reply? Or do you choose one of the service functions to indicate backwards, or do you do it for all of them?
Sorry.
So I think what Joel was saying is, what if you have two hops in the chain are served by the same service function forwarder? Right, like service function 1 and service function 2 are each doing different things, performing different functions. And you said that you send one reply back for each service function, correct?
Yeah.
What if? Yeah.
Is that okay, Ting?
Okay.
So there is a difference because this specific is thought of effectively tracing RSP. Okay, so what you're asking is you are asking about a little bit different functionality when you're saying, okay, how many of that kind you have? Okay, so I think it's very useful option, and we can talk about how that would work and what could be effect. But this particular proposal is more about mapping SFP to RSP.
Although I will also note that the SFF may not actually know how many instances are behind it. So we have to be careful how that's handled.
Yeah,
It's a valid question, but we need to be very sensitive to the deployment ranges in answering the question.
Yeah, but I think that, again, it's interesting functionality, and I agree with you, but it's somewhat different from what we thought for this proposal.
I think I understand. I'll think about it a bit more and I'll talk
Yeah.
to you later or something.
Yeah, just on the list or just reach us directly. Thank you.
John Strassner. So this assumes that every SFC knows what it's doing and is itself an atomic block. But what if I have a group of SFCs that form a chain? And
John, please clarify. There are SFFs, there are SFs, there are classifiers. There are no SFCs. So please clarify your question.
So if I have a policy that chooses between two different groupings of service functions, what other people...
That becomes separate in the SFC construct, that becomes separate service function paths. They're tracing the RSP that realizes a single SFP.
Right, but what about the grander vision of being able to identify alternate paths? So...
Different problem, I believe.
Yes.
Yeah.
Again, that is a little bit different angle, and if you can help us to understand what needs to be tested, let's work together because it's not what we intended with this proposal. As Joel pointed out, we are taking SFP and we are mapping RSP of that SFP. So SPI characterizes SFP, but it's not necessarily one-to-one mapping to RSP. So trying to find how it's balanced, and there might be some other proposal, and there is a proposal that Ting will present of basically what identifies RSP within SFP. Not this draft. It will be later.
I'll take it on the list.
Thank you.
Okay, there is one other implication in what, oh, sorry, go ahead. You were ahead of me.
you can follow.
Okay, there's one other implication in what you just said, Greg, and in what you said, Ting. You said you're tracing the RSP. We do allow in the architecture that there may be multiple next SFFs from a given SFF. So SFF1 might have two different nexts for different flows. The packet isn't here because this is active OAM. How are you tracing the correct RSP?
That something that basically led us to one presentation that Ting will have, because really the question is, yes, their architecture states that SPI characterizes SFP, not RSP. So basically, working on this, we realized that we don't have a method of identifying RSP within SFP. And there will be some proposal. Again, it might be not the way we all agree how to do it, but at least, yes, you're absolutely right. There is a problem of, there is a question of how we identify RSP, the flow within SFP.
Wow.
Your name?
Kent Leong. So actually, I was going to follow on the comment earlier. I was thinking before maybe your response there is that it might be good to have a section to clarify kind of the load balancing aspect, right? Because I think the question that was raised earlier was that, if there are multiple instances, that SFF can reach for the same SFP, right? then, which one do you respond with as the identifier, right? So I think, there are different cases, right? In the case of stateless, there's a hash function. So there's some way of selecting which one, and that could be the one that's returned as far as the path indication. And the other one is stateful, right? If SFF actually is stateful, then you would know which one, despite the fact that there could be multiple SF instances, right, in the path. So anyways, it might be good to just have a section to cover it. That was my comment, I guess.
Contributions are welcome and co-offers are welcome.
Yes, thank you. And the draft has been presented the last meeting, and we, according to the comments from the last meeting, we update the draft, and we already have SFCOM that is in the monthly OM, and we make the update according to this draft. And now the draft is the extension of SFC echo request and reply. And rather to introduce new SF ID registry, we prefer to refer to section 10.5, new service type registration of NSH BGP control plan draft. And we add some security consideration section. Next. And the security consideration in this draft is also based on the NSH draft security consideration. In addition, since service function subtier discloses information about the ISP, the approved COM request package may be used to obtain network information. So it is recommended that implementations provides a means of checking source address of COM request message. The source address is specified in SF's source tier, which is introduced just now. Next.
So I had a question about that. How does the implementation determine the source address? So it's checking against the source address to determine whether or not to reply.
Yeah.
How does it know whether it's a valid source
address to make sure the security is acceptable.
No, sorry. So how does it know whether it's valid or invalid? The source address.
And the source address carried in the SFCOM request echo request message.
Yes, actually, thank you, because I missed to mention that in my presentation that if we not use IP UDP encapsulation of echo request reply, so we need to have source TLV to know where to return the reply, right? So basically, that's what Ting said is reference to this missing part that I missed to say. It's my mistake.
Maybe I misread the draft when I was reading it. So is it comparing the source address against something else in the packet? So it's comparing two pieces of information?
Again, there could be a different policies how we establish whether the source of this active test packet is valid. Okay, so again, it's somewhat outside of scope of the document, but it's a suggestion to have certain mechanisms that verify that this is authorized source to send test packets.
That's what I figured. So that was going to lead to my next question, which was, should we reply with an explicit packet indicating that it was denied if it fails? Because otherwise, a misconfiguration in the network relating to the control plane can make it look like there's a problem in the data plane.
I think that logging some information will be sufficient. Replying might be, again, exploited as an attack vector.
Okay, thank you. This is the second slide about the SFCOM. It's about how to specify the return path of echo reply. In this draft, we suggest to use reply service function pass TLV in conjunction with reply mode field set to reply via specified pass in echo request to control the return pass of echo reply control message. Yeah, okay. This draft is also has some update according to the comments received from last meeting. SFC echo request has been introduced in multi-layer OM. This draft will give some modification according to that draft. And as the same, we add some security consideration section. Next. Same with the last slides, the security consideration from NSH also apply to this draft. In addition, the SF return pass extension defined in this document may be used for potential proxy attacks. So in order to prevent using SFC return pass extension for proxying any possible attacks, the return pass SFP should have destination of the sender of the echo request to identify the SF resource TLV. The receiver may drop the echo request when it cannot determine whether the return pass SFP has the destination to the initiator. That means when sending echo request, the sender should choose a proper source address according to the specified return pass SFP to help the receiver to make a decision.
Well, this seems not quite to add up. If the entity that is generating the reply already knows who the source of the SFP is supposed to be, so it can validate the source TLV, then it doesn't need another validation to compare those two, because it's like, okay, check that the reply is going to the correct source. So it's, and if you're not validating against the external information, then I'll simply lie in both who I want you to send the reply to and who I claim sent the request.
Okay. Here's could be another scenario that we thought of, and then something that was first developed for MPLS LSP ping, proxy ping. When we ask somebody to send echo request, but return the reply to a different entity. Again,
then you need to rewrite these security considerations a bit.
Okay, thank you for the suggestion, and we'll look at this. But the thought is that, again, to have some flexibility on who sends and who receives the reply. It might be two different entities.
But then you need to be much clearer on the security considerations. Don't try to fold them into one paragraph. It's okay.
Okay, we'll work on it. Thank you.
Any other questions on this while I go to the next
yeah.
slide?
Okay, in these slides, we want to have some discussion about the scalability of SFC. SFC scalability is the capability of the SFC that is resilient to scale out or scale in horizontally or vertically. These are the terms we define. And we describe 4 scenarios of scalability in the draft. The first scenario is join. Join means SF can be added into an existing SFC so that the SFC has more service function. And the second scenario is about redundancy. Redundancy means one or more SFs are added into the SFC to meet the protection or load balance requirements. The third scenario is about bypass. That means some SFs are bypassed since no need the service function anymore. So the SF is not, the traffic will not traverse this SF. And the last scenario is about failover. That means some SFs are removed because of failure, is removed from the SF because of failure. We identify these four scenarios into four categories. For joint cases and redundancy cases, we see the SFC has been scaled out. And for bypass or failover, we see the SFC is scaled in. Next. This is some detail about SF redundancy. We think that SFC redundancy should contains two cases. One is SF redundancy. SF's redundancy means one or more SFs are added into the SFC to meet the redundancy or load balance requirement for some certain SFs. But for SFP redundancy, we think that the SFC is scaled out to two or more SFP paths, and one SFP is redundant to another SFP, so that the two SFP can protect each other or load balance. Next. According to the first scenario we just presented, there are some requirements. One is about the data plane requirements. This requirement is based on load balance scenario. For load balance or active protection, flow ID is needed to differentiate the SFP in SFC. So we have two options to add such flow ID. One is to add the flow ID into the service path header. Another is to add the flow ID into our metadata. The metadata type should be true. Next. And we also have some requirements in control plane. In control plane draft, there are four interfaces has been defined. And in this slides, we have some requirements about the C1 and C2 interface. C1 is the interface between control plane and the classifier, and C2 is the interface between control plane and SFF. For C2 interface, we suggest add two messages. One is register message to SF to notify that SF is going to be joined, and then installing new entries in the SFP forwarding policy table. The message contains indication that the SF is joined as a new SF or as a group. And for the register message to SF is to notify that SF is going to be removed from SFC. And the message should also contain some indication that it is removed from SF or from a group.
Let me ask a couple of clarifying questions here. First, the C1, C2, et cetera terminology is no longer part of the working group terminology, so we should probably avoid using it. The document that brought those forward is not any longer a document we're working on. That was the conclusion of the working group, therefore we can't use those.
Okay.
I want to point out on this slide, the NSH document has gone to the RFC editor. We are not going to change the NSH encapsulation, the base, without a dramatic reason. If somebody finds it don't work, if we broke it, we'll fix it. That's the way the IETF works. But having gone through working group last call, IETF last call, and very long IESG discussion, I'm not touching that without a very strong reason, please. Now, having said that, these two things you describe under C2 look to me just like whatever it is going to be used to configure an SFF's table for forwarding to SFs. Those are not, we're not defining those messages. They will appear in the Yang as messages that already need to exist, there doesn't seem to be anything new needed for those cases compared with creating a service function path in the first place. Is there a new requirement here? What you should focus on here is new requirement, please. But Kyle, you have.
I have two comments, so both related to what you're talking about. So with respect to choosing between the NSH extension or a piece of metadata to add the flow identifier, I definitely prefer, I mean, aside from the fact that we don't want to reopen NSH, the metadata version of the flow ID is 32 bits. And the other version is only 8 bits. And I don't think 8 bits carries enough entropy to effectively load balance. I mean, if you have more than 256 candidates for a specific load balancing group, you just can't do it. And that's really limiting. So I really strongly suggest that we go with whatever solution allows us to have more than 8 bits of flow ID. And the second thing was related to this requirements. Maybe what we want to talk about with respect to joining and leaving the forwarding plane is what it means to effectively join with minimal impact, right? So we can add a new service function to an SFF, but how can you do that with minimal impact? And maybe that's something we should talk about in the requirements, rather than just saying we need a message to do this. Maybe we need to talk about what the implications to how the SFF needs to implement that message are. Anyway, thanks.
Okay.
So no, you're not going to comply with that draft. That draft is no longer a working group draft, so don't worry about it.
Okay, I see. I will modify the draft. And any comments about this draft anymore?
P-man. We're still in there over here.
Okay, thank you.
Okay, Greg, you have like 10 minutes for whatever's, yeah, we originally gave you 15, you've got 10 at this point.
So this is an update on a little bit different direction of OEM. Using the classification of RFC 7799 alternate marking method, it's a hybrid method. And our proposal, so this is update, just set a context or switched from their echo request reply. The alternate marking method creates a certain sequence of packets that are marked the same way, and then within this batch of packets, we mark packets that are used for the measurement. So different method of marking allows us to do either loss measurement and delay measurement, and using the two flags allows us to do time measurement more accurately. So this update proposes to use double marking method for residence time measurement. And the advantage that this use of alternate marking method allows us that all the metrics can be calculated on a node and then exported aggregated, rather than exporting their numerous timestamp and calculating offline. So that's the advantage of this method comparing to some other methods. Yes, this is our proposal that we have in this document from the beginning to allocate 2-bit field and use them, one signify as a loss measurement and the second one as a delay measurement. I should note that yesterday we had a presentation in IPPN working group. That's where work on alternate marking method progressing, and we're moving to Conclusion, the new work proposed on compact method where some other methodologies to use either single bit for the multiplex marking or using hash on some characteristic information in a packet may allow to minimize the use of additional fields. But use of double marking method is something that already been deployed and we discuss in other working groups. So that's something that we ask SFC working group to consider allocating a mark field of 2-bit positions. So here for the residence time, the residence time can be measured SFP end-to-end. At the same time, a residence time can be measured as a nodal on SFF, and residence time can be measured subnodal per SF. An advantage of using alternate marking method that the measurement of and calculation of all performance metrics related to the residence, whether it's nodal or subnodal, can be done on SFF without exporting each and every timestamp. So basically, we have a different measurement points whether we're doing a nodal or subnodal measurement. But the advantage is that because and if we have the mark field in NSH header, then we can apply alternate marking method to create with 1 bit, with loss bit, a batch of contiguous packets marked the same way, and then use a delay flag to signify their packet that we want to do residence time measurement. And then can be in addition to measuring delay characteristics along the path as well. An advantage of, again, the general advantage of alternate marking method that these packets, these measurement points can be enabled on the fly at any node, any element in SFP, but more likely it will be SFs. Next slide. So I'm thinking that I'm good within 10 minutes. Questions, comments, and we appreciate the consideration of working group adoption. All right. Thank you.
Frank? No, that's the wrong one. Sorry. I was trying to get to Frank's, but there. There we go.
All right. So next slide. So this is about in-band OEM, or sorry, in situ OEM in NSH. So just a quick reminder on what IOEM is. IOEM is a method to go and carry within the user packet itself metadata to help with OEM operations, which is, well, information like node ID, ingress interface, egress interface, timestamp information on when a particular packet visited a node, and so forth. The overall work is progressing as part of IPPM working group to go and define in a transport encapsulation independent way a variety of these pieces of metadata or data fields that are accumulated and assembled and collected as the packet progresses through the network. And if you go with the classification in 7799, it's hybrid type 1 OEM. So as I said, we've been doing that work in IPPM. We are specifying the header fields. The documents are getting stable, but we need to go and carry these data fields. And NSH is one obvious contender for carrying these data fields. So we're doing that kind of shopping tour through the various working groups right now. And well, we are here to go and do the shopping with NSH. Next one. So we came up with a proposal. Can you just flip the, okay. So 0.00 version of the document has a proposal in there on how to encapsulate IOAM metadata into NSH. And there is, if you read through the IPPM document, there is a variety of OEM types for IOAM. One is edge-to-edge, another one is for proof of transit, and another one is for hop-by-hop tracing that then define individual TLVs. So what we decided doing is to go with a relatively flat structure. That means for every single class of IOAM metadata, we define an X header. And then within there, you have the TLV structure. That's a flatter approach than using metadata type 2. But those two alternatives exist, and well, we're happy to go and discuss what the best approach for that is. But here is an example how trace data would be encapsulated. It could well be, if there is proof of transit there as well, you'd have another next header for that. If you flip to the next slide, I think it starts to, this is really messed. So what happened?
We uploaded it and it got auto-converted to PDF, and this is what you get. If you send
Well,
us,
I
everybody
think-
understand, if you send
I
us
think-
PDFs, you will get what you send us.
Oh, I think
If
we
you
saw,
send us PowerPoint, you get what the tools
I
do.
thought we sent you PDF. Anyway,
Quick
not
question.
a problem.
I have a question, Kyle LaRose, Sandvine. The previous slide, just about the next protocol. My only I like this approach, but my only concern is that the NSH specification, as currently stated, says that devices which don't understand the next protocol should drop the packet. And so if we're inserting the IOAM trace into packets, it
I
might
believe
not.
it's devices which need to and don't should drop.
Right.
Because I think there's already a caveat, because most SFFs aren't even going to look.
But I mean, consider an SF that is already out there in the wild, right? Implementing NSH is currently specified. If we start inserting IOAM trace into these packets, it might drop it. I mean, it's just like, I like this approach. I'm saying that. I
Yeah,
just, you
there's
know,
more problems with that if you flip to the next slide. So,
Greg Lusky, ZT. So with this approach, what the value of OBIT?
which is why I wanted to get to the next slide.
Okay,
Yeah, I
and
don't
the
know.
next
Try to
approach.
do that?
No, and the
Yeah,
next.
can we
No, and the next
can we
question.
let Frank go through his presentation first, because I think
Because
some of these
there is
questions
a load
are
of
gonna
these
get
problems
answered.
I bubble up, and then I'll let you speak
Yeah,
to
please
those.
go
right?
ahead, Frank.
So there's, I think the two things that are pretty obvious here is we try to not nest TLVs unless we have to, which is why we ended up with the approach to have basically three main code points: edge-to-edge, proof of transit, and tracing, and then do the TLVs there within. We could have done metadata type 2, which leads to a further level of nesting, and I tried to go depict that with a kind of little bit of a graphic on the right-hand side. The funny thing is we have the original implementation that we first built in VPP uses actually metadata type 2. In software, not that big of a problem. In hardware, it leads to an iterative lookup, and an iterative lookup in hardware is relatively expensive. So that's one problem. The other problem is, and that's the very point that you're raising, Greg, and that, well, I posted the draft, and I think 5 minutes later, I first saw the first reply from Jim, and then another 5 minutes later, I saw the second reply from Joel. So said, what is the OBIT for? If you read through the architecture document, so that's 7665, right? It does this clear distinction between OAM traffic and user traffic. Now, our assumption is that we tag with IOAM virtually all user traffic. So are we user traffic now or OAM traffic? I don't know. The funny thing is that an SFF will only look at myself and my metadata if I set the OBIT. So I need to go and classify myself as OAM traffic. And eventually, if you have an operator that is just interested in, so say, proof of transit and verifying that your path is correct, you'd classify all user traffic as OAM traffic. Do you want that? Maybe you do, because your SFF is really capable of doing that. If you have an SFF that interprets the OBIT as pun to control plane,
No.
Well,
Um,
not so much, right? So that's one of the delicate things that we have. So I think we need a resolution for that particular one. And I very much welcome, well, thoughts on that particular question, as much as I value thoughts on, should we go nest and do metadata type 2, or should we go with flat as what we propose right now, which requires us to ask for more code points. And well, eventually do multiple lookups until you kind of go to the end of the next header chain. So there is trade-offs between the two, and there is no easy answer. Now, Greg, it's
Yes.
all yours.
Okay, so I disagree with your interpretation of OBIT because the OBIT allows you to have OBIT set and next protocol to point what your payload is. So there was extensive discussion, as I recall, about meaning and interpretation of OBIT, that OBIT means that there is some OEM data and doesn't mean that this is OEM packet. And that's why we propose for active OEM to have OEM protocol type in combination with OBIT. So to explicitly state that this is active OEM packet and nothing else. Because what you have, the problem then, is what you put in protocol if you have your IOEM. Would you put IOEM in NSH? Then where the payload will be signified. The idea, my understanding of OBIT, and actually I was very much for just dropping OBIT, releasing it to the unused field, because I think it complicates. But as it is, their interpretation should be is that there, in combination with some protocol, then there is some data go fish in the metadata.
And as I said, I don't have a problem. We can go and,
Right?
at the minimum, we can go and specify and explain that very thing that we don't do right now in the
Because-
draft. So the next version will have an explanation of that. And I don't have a problem with setting the OBIT, but I think we need some guidance that exactly what you're saying, right? If you set the OBIT, that it doesn't mean, oh, this is a packet that you're safe to go and process in the punt path. I think that interpretation should never ever happen. And if we're explicit about that, I don't really have a problem with that.
In my mind, what particular implementation does with a packet, its implementation details and not commanded by their group. My question to you is, what option you recommend? Because one thing is asking working group what you do with your document. Another thing is that what you propose to do. What type of encapsulation you suggest?
Well, that's what we have in the document. And as I said, in order to be mostly compliant with what the operation is, we probably would need to say, well, if you want the SFF to look at the whole thing, we need to set the OBIT.
No, but again, are you proposing to use, are you prefer to use MD type 2, or you propose to use a payload? And if you propose to use a payload, where the payload goes? Because you, to me, looks like you're creating active OEM packet if you use a payload. Okay, but
We're not using
then
a payload.
where's your payload? Next protocol?
Yes.
Yeah, next protocol.
Yeah,
Of course,
the
next protocol.
IOAM header has a next protocol field. He was
It's just a
quite
chain
clear
of
right
next
there.
protocol headers.
I can recall one particular member of community who was objecting to that idea that was presented in overlay OEM document, saying this is a very wrong idea.
There are issues with this. For example, if you use this kind of next protocol identification, it means you have to have made sure that any SFF that has to look at the underlying packet understands how to skip this,
Correct.
and that any SF in the chain, because SFs have to look at packets,
Right.
understands how to skip that. That may be an acceptable constraint, but we should make sure we call it out in the
No, no.
document.
You're exactly right, and which is why, back to some of the IOEM claims, it's a domain-specific feature. You want to make sure that your SFFs are actually capable of doing that. But it is a constraint, yes.
Right. And then the question is, what happens is if SFF cannot do that?
Good point.
Because in my view, using metadata is less intrusive because, well, I don't understand this metadata. I may send it.
I don't disagree, right? So which is why we, from an implementation perspective, we went with the nested approach first, but it has implications for hardware,
No,
and maybe
right.
you give Mickey a chance to go
But-
and
Yeah, so go,
comment on that.
I'm
What-
going to
no,
interrupt.
Okay.
Greg, please, I'm going to interrupt here. Let's take this conversation offline because we're going to go backwards and forwards, and we don't have time.
Okay.
So,
Take it to the
so
working group list.
next question, please.
Yeah, I just wanted to point out a couple things about
closer to the mic.
Yeah, I wanted to point out a couple things about the obit. So what was already mentioned was this question of the context that people associate with the obit. But if you look at what's actually written in the document, one issue I have is that the default behavior, if you do not support any OAM, if the obit is set, is to drop it. That's not really the behavior that we want here. And because of that, I'm wondering whether it might make sense to use one of the undefined bits if you think setting a bit is really what's necessary in order to look further into the packet.
That's a valid question, given that the assumption is that only upgraded devices will need to understand it. We could take one of the reserve bits because we wouldn't care that existing devices wouldn't get it unless they had to look at the payload, and then they might get confused. But that's a good discussion for the list. We do have other reserve bits. We don't have lots, but this is if this is an important use case, we could assign a second bit to this specific use. I don't think that has a big effect on whether it gets punted or not. I understand your concern about
Yeah,
punting.
it's separate than that, but well, no, it's not entirely separate. It depends if people treat the obit as punting or not, which is not what the document says, but it's a discussion.
Okay, I have 2 more slides. Maybe we give them a chance. Ha! Again, wonderfully messed up. So, what about security? And well, maybe Tal, you want to go and bring that up. But what I learned is that security is still something that SFC is supposed to work on as a working group, and that was one of the comments to the main document. While back, we presented proof of transit also to SFC. What is the mechanism? We basically take a secret, we split the secret, we give every single hop that needs to be verified a piece of the secret, and as the packet traverses through the chain, you pick up the pieces of the secret, and then you can either reassemble the secret or you can't. If you look at the latest version of the proof of transit document, there's 2 basic mechanisms being proposed. One uses nested encryption so that you piece together an onion, and then later on you verify by piecing together the onion yourself again whether the 2 onions compare. Or we're using Shamir secret sharing. Shamir secret sharing is computationally far more lightweight, with the downside that you don't preserve the order as you would do with nested encryption. So the 2 options are there. They could be both used depending on the requirements that SFC has within this very context. So it's kind of tied to, well, we carry the metadata, but we can also carry proof of transit metadata somewhere else. So it can be really orthogonal to IOM per se. But it's there, and it solves a particular problem that has been pointed at by IESG in the review. If you go to the next slide, it basically captures where we are. As I said, the data fields are being defined, and it's pretty stable by now in IPPM. We need to go and encapsulate. We're on this shopping trip. NSH is here. There's other working group other documents being proposed to other working groups. They're listed up here. And well, we already received some feedback. What we want to go and stabilize the current proposal and see what the main line of consensus from an NCAP perspective would be. The other question is, do we want to go and adopt proof of transit here in order to solve the security problem?
That this was certainly raised, and I would certainly, I think we need a little more clarification before we're ready to ask the question of the working group, but I think it is an important thing for the working group to consider.
Just one quick question. So I understand that for VXLAN, because it doesn't have extensible header and the fixed access header, you don't have other option but to use in payload sending IOM information.
Well, VXLAN GPE has also a next header mechanism. So if you read through that document, but I think we're going to go discuss that in Lisp, and maybe we take the discussion there.
Right. No, just the thing is that I think that it might be good to understand that in encapsulations that have a flexible or extensible headers, metadata TLV is an option. And in some other networks, it's not an option. Right. So it might be one of the reasons to think that do we want to have consistent mechanism across different networks, which might be a good thing.
Absolutely. But there is, well, it's not so straightforward, right? Given that some protocols come with the ability to carry TLVs, others don't. So there is not one solution, which is why we're doing the shopping tour, apparently. Thank you.
Who's up next? Let's see. Adrian.
Let me find you.
That's it, that one. That's
Yeah.
it. How much time?
Whoops, just a second. Let me check your time. You are slated for 15. We have that time for you.
Okay. It's a nice big pink box in this room. Right, so using the MPLS data plane to achieve SFC. It's a draft we've been working on for a little bit, and rightly pointed out that we should talk about it here as well as in MPLS. So what we're doing is reusing the SFC architecture that was developed here. We're not changing that work at all. Obviously NSH now has just gone through to the RFC editor, which is great. And the charter that led to NSH was to talk about a generic encapsulation, agnostic to which layer it was applied at, which is fine. This draft is looking at specific encapsulation for an MPLS forwarding plane. And what we're doing is bringing that both here and to the MPLS working group, because we need review and opinions from the experts in both of those places. Some of that work will need specific MPLS tweaking, but it doesn't, in our opinion, change the SFC architecture at all. And we are fairly agnostic as to where that work gets done, and hope that the MPLS and SFC chairs and ADs will work on that. I mean, I have an opinion, but don't really mind. Do I have a pronger? No, you don't. All right. So this is a joint set of slides that I'm using in MPLS as well. If this architecture picture surprises you, either I'm wrong or you've been asleep. Next slide. So objectives and non-objectives. I think this slide is probably the most important of the lot, right? We are not trying to replace or obsolete or deprecate or any other adjective NSH. NSH is just fine. It does its job. Great. What we're doing is looking at an environment where MPLS routers that are already deployed can serve as SFFs without changing their forwarding plane, and to be able to forward packets at line speed, so not throwing those packets out into some piece of software that interprets the NSH. What that really means is that this is a technology, an approach that allows you to migrate. Okay, it allows you to put service function chaining into the field now while people are working on NSH. It's not an attack on NSH. What we do in this draft is support both modes of MPLS forwarding. So that's label swapping and label stacking, otherwise known as segment routing. And actually there's an advanced function in there that allows us to mix and match swapping and stacking, which has some specific use cases. But principally we're trying to look at how you can achieve service function chaining using swapping or stacking, and trying to do that in a common way. Go ahead and interrupt me.
Carlos Piñataro, Cisco. Adrian, I understand what you're saying, and I think it's super important to be able to run service function chaining on an existing MPLS data plane. Have you considered running NSH over MPLS and compare and contrast that to this other method and see which one has more strength?
So yes, it did consider it, but didn't really compare and contrast. So the consideration is that if you run NSH over MPLS, then really you're using MPLS purely as a tunneling mechanism. So when you arrive at the SFF, you're stripping off the MPLS and going, oh, I have an NSH. And something has to process that NSH. If your box is a dedicated MPLS router already, to process the NSH, you're going to have to throw that to software. That's the step I want to avoid. Now, of course, you can do that, that implementation. You can do that using the existing NSH spec, no changes to anything, knock yourself out.
No, that's good. And I'm not suggesting that, you have to do that necessarily. I was curious whether the objective was to use MPLS as SFFs or whether the objective was to run NSH on an existing MPLS infrastructure, right? Because the first one is a solution, the second one is a problem.
Right, the former. The former is, so I want to be able to do service function chaining using an existing MPLS router as an SFF.
Thank you.
So the fourth point here then, we want to get as much SFC functionality as possible, but we are aware that there may be some sacrifices, some trade-offs, because the NSH was developed in order to achieve the full SFC functionality, and the NSH is not MPLS. So there's clearly potential for mismatch. We think that we get most of the function. The big wrinkle is around metadata, but we have a proposal for that. And then lastly, there's a BEST document that talks about a control plane for the NSH variant of SFC, and it turns out, in our opinion, that control plane mechanism will also work for this MPLS encoding, and we're not touching it. So, yes, thank you. The overview of the solution. The overview of the solution is basically everything is built on a label pair, a two-label stack entry pair. Obviously, the labels cannot be in the 0 to 15 range, but apart from that, we have the full 2 to the 20 available. And with this unit, which is a context label and a function label, we're able to achieve both the swapping and the stacking approach, but there's a slightly different interpretation. So for swapping, we use the two labels, one as the SPI and the second one as the SI. So that's essentially, it looks just like the NSH, but it's achieved using two label entries, and that gives us a TTL in there as well, so we can use that. There are some little limitations that show up because we only have 20 bits to play with. The SPI in the NSH is more than 20 bits, so we have a constraint, but I think that's okay if you know what network you're managing. It might be a problem if you were trying to do NSH halfway across the network and then flip into MPLS. Carlos has another question.
Carlos Piñataro, Cisco. And I apologize because I didn't have time. I wanted to read this in detail. I didn't have time, so I'm working through the method. In this case, Adrian, you're neither doing swap nor doing pop. You're doing a combination of both, right? Because you need to pop everything, save it somewhere, process the payload, and then push, right? So you're not, it's, one of the...
No.
So for
let's look at the NSH version, okay? When an NSH packet comes in, you don't strip the NSH before you send it off to the SF. But when it comes back, you're doing effectively a swap because you're decrementing the SI. So there's no difference.
On the NSH case, if you have an NSH aware SF, the SF itself processes the NSH, right? If you have an MPLS SFC aware SF, it's not going to be doing MPLS. It's going to be doing popping, saving, and then pushing.
So if you have a non-SFC aware SF today, you put a proxy in, and the proxy has to strip off the NSH, store it, and reimpose it, and modify it. No change, okay? So yes, future SFs will be SFC aware and handle NSHs, but we're not in the future yet. And this is trying to handle what we have now today.
So your SFF is an SF proxy essentially as well?
Or you put a proxy in a separate box. You know, the architecture allows you to put your proxy somewhere in the path between SFF and SF.
Okay, Greg Mirsky, ZT. Their assumption is that SI label is bottom of the stack. How that will work if we have OEM and then we need to put a GAL label below? If you have SFC OEM, are you talking about? Or you're talking about? Yes, SFC OEM. Yes, well, because MPLS OEM will go on the tunnel label.
Yeah, so it's already stripped off by the time you get here.
Yes, basically then there is no need to have SFC at all.
Right. So given that we haven't yet worked out how we're doing OEM with NSH, I think it's premature to say that the way you would do OEM in an MPLS encoding is by using a GAL. You might be putting it, for example, in metadata.
Okay, but have you thought of how to do OEM with MPLS encapsulation?
Yes.
Well, but you don't have the O-bit, so
we don't have
there are some complications.
We don't have the O-bit, so how do you know that that there's OEM present? Well, how do you know there's OEM present? You know, it's like define how you know, and then
GAL label.
Well, you could use a GAL label, and that would be fine because there's an assumption then that the people processing the packet know how to tell whether there is OEM present, in which case they will process it.
Yeah. Okay.
Andy Malice, you could have a special alternate context label for the SPI, which implies that there's OEM involved as well.
That's a good point. Yeah, I mean, if since we're down to 20 bits in the context label for the SPI, we could burn a bit for the O bit if we.
Absolutely, yeah.
Okay, so the stacking approach, as I said before, we tried to do a single document to cover stacking and swapping. So we put the two label unit in there, but it appears multiple times. And in this case, when you arrive at the SFF, you're going to be popping a pair of labels, and that pair of labels gives you a context and a service function. And a way of using this is that the context is the segment routing instruction to get you to the SFF, and then the service function label under that tells you which service function to deliver to. And then, as I say, you pop to, and that gives you then the next context, so you can forward again. Slide. Yeah, what about metadata? Obviously, metadata is important. I worry about the insertion of an arbitrary amount of metadata between the MPLS packet header and the data, the payload data. What we've done to circumvent this issue is allow you to put in a label that says this is an index to some metadata that has already been passed. And that indexes a store which may have been populated from a control plane, from an out-of-band management plane, or as described on the next slide, in band. This works really nicely for per SFP metadata. It works nicely for per flow metadata, where there's multiple flows in an SFP. It doesn't work well for per packet metadata. So depending on our use cases for metadata, that this may or may not be perfect. Next slide. So how do we push metadata in band? This is very, very similar to the next proto is none in NSH. Essentially, you send a packet that is going to follow the SFP, so you put the context label and SF label on just as normal, but under those you put a special purpose label that says, here be metadata. Instead of user data, what follows is metadata. So the metadata will follow exactly the same path as the real packets would, but they've got an indicator that what follows is metadata. And into that payload, you put an LTV where the type is lifted from NSH, and the metadata that follows is formatted just like it would be in NSH. So essentially what that's saying is send your metadata interspersed with your user data rather than in the same packet. Next slide. So where are we going? We can always polish the draft, and no doubt there's quite a lot to be done. But actually, we think we've got to a fairly stable position with the support for both swapping and stacking, which took us a little bit of headbanging to come up with a consistent approach. It fits, as I say, with the control plane. We think it's pretty obvious as this transition technology. And we think that probably it goes in the MPLS charter because we're defining special purpose labels, and that working group would probably freak out if anybody else touched them. But it obviously needs discussion here because it's service function training. I finished.
Speaking as a co-chair of the SFC, no, we're not going to define MPLS special purpose labels. That would be a really bad way to work cooperatively with our fellow chairs.
Wim Hendricks, Nokia. I have a question on the stacking proposal. What? Wim Hendricks, Nokia. On the stacking proposal, if you do the proxy, how I think you have to define a new behavior on how the proxy will work, because the proxy in the stacking case.
Right, so I'll just repeat that because you're a bit quiet. If we're doing the stacking approach, you're saying the proxy has to have a little bit more intelligence than.
If it's in the middle of the stack, it needs to skip,
right. So
some.
Yeah. So just as a proxy in NSH has to rip off the entirety of the SFC encapsulation, the same would be true in the stacking or the swapping case, that the whole lot has to come off. And in the stacking case, yes, that is a more complicated action because you've got to work out how much to strip off.
This is Zafar. Regarding the work, which working group, I think this work should start here because what you go in terms of the special label and all those things really depends on the need for it. It's not going to be defined just because of sake of defining it. And the only working group that can comment very well about need for these things is this working group. So that would be my comment to chairs, that we should start work here. If there's a need, then yeah, there's a complement, like there's a supplement document or something that happens in MPLS.
I agree. And the SFC architecture gives us a lot of guidance on that. And hey, I'm here.
We need to close the line. We're running out of time, please.
Kent Leon Cisco. Actually, I just have a question here. I was reading another draft which has segment routing plus NSH, right? And in that case, that they're using NSH basically to carry the metadata, right? So I guess I know there's MPLS segment routing, so I guess I wasn't sure what the relationship is with that one.
I think there are actually two other drafts around talking about service function chaining with segment routing. One is next on the agenda, and one is in the Spring Working Group and is quite new. And I'm aware that Spring has always had in its mind that that service function chaining could be achieved with segment routing.
Yeah.
And so how does this relate? Well, we're focused on MPLS hardware.
Oh, okay. Okay, I see a little bit slight difference in how NSH is being used, so that's why I brought it up.
Yeah, just a comment. I think they're related because segment routing is also MPLS hardware, it's SR MPLS, so they're very related.
Yeah.
Next presenter, please. I am your clicker.
Hi. Yeah, my name is Shaowen from Juniper. On behalf of all the co-authors, actually, we propose this unified segment routing file for network service header, service function chaining somehow. So basically, we propose this similar idea for the unified segment routing, which is source-based routing, which combine the benefit for MPLS and any tunnel in between. So previously, the work working on this service chaining proposed in 2014, but the work not well adopted by the MPLS working group because of at that time service function chaining is not a major use case for segment routing or somehow, and also some background on the SFC team at that time they are working on focus on the SSH header somehow. But this time we propose this one, sorry, and please go back. We propose this new idea somehow in October 2016 because of we believe the service function path will be better benefited by this combined IP and the MPLS function, which is in between any router, any switch, which can handle UDP, can handle MPLS, can help with this service function path somehow. Then the next, so this one is fully defined whatever path the service provider want to working on the telco cloud, the mini data center, distributed data center, then they can chain the function together here. Next, please. So the proposal here is kind of you may have a multiple data center, multiple functions here. And after the BNG, after the P gateway somehow, you have the service function classifier here. But we do not kind of try to differentiate between the SF and the SFF. So we assign the label for kind of doesn't matter. The label can be one standing for the SF or SSF for forwarder. And in the middle, if there's something, some boxes cannot support the MPLS segment routing or somehow, we also can support by the UDP tunnel to pass through somehow. Then in the meantime, we not kind of try to compete with the network service header, SH. which we think is very good for the metadata container somehow. So we take the pass as a service function pass and put into the MPLS label stack together with unified stack routing and with UDP GRE tunnel in between. But the metadata we keep internally in the network service header here. So if you look at the label allocations, very similar with traditional stack routing somehow. But if, for example, for the SF forwarder, after he processed the whole thing coming back from SF1, then they saw the label for the next SF forwarder, which is not the MPLS-based interface. The best path may be the UDP one. So there will be a label mapping between the label to the UDP tunnel in between here. So next, please. So we actually highly appreciate all the work in the SFC working group here. But we propose to keep NSH header as a metadata container here. So then we also can propose a method to working between the network service header and also the unified stack routing here. So the SPI function we suggest will be handled by the so-called unified MPLS, which is can working with any router, any switch, almost. Then with very high processing performance line rate forwarding. So the transportation only taking care about finding the path. Then the NSH header part, you also can contain all those information for the metadata. Then you also can combine the usage of SI and SPI to get all the label stack and so on. So if you go next, okay. So this is the information here. One of the processing here, we know that the source function here might be some kind of a double interface somehow, or maybe for analyzer, you only need to throw the traffic to the source function here. So this time we actually simulate one function which you need to put all the label information and the NSH header information from SC, then go all the way to the SF forwarder router here. Then on this router, because the SF might not be understand the stack routing at all. So in that case, not a stack routing label will be set up somehow. So SFF will assign the label for the function, the VNF somehow function. But when we sending the traffic to the forwarder for further processing, we actually get rid of all the stack routing pass information. We only pass an NSH header here. But when they come back from maybe another interface to this router, and we put back all the label stack here. So that's a proposal. If you can go next. Yeah. Sorry, if you can go next, please. Yeah. Sorry, this is an old version somehow, but we actually try to highlight to combine the benefit of both stack routing and the network service header to help the service function chaining here. So there will be all the benefit leverage the existing router switch to define the path. And all the metadata, all the subscriber information, all the user information will be kept in the NSH header here. Then build on for MPLS and UDP all the capability here. Okay. That's all for my session. Any
okay.
question?
Can we go 2 slides back? Yes. Greg Mirsky, ZTE. So I probably this is just for the shortness of presentation, but I think that like in segment routing, their SFF label can be within MPLS tunnel, which is swap tunnel.
right?
Oh.
And that's basically, you don't have to specify it on the classifier because will be like LDP loose source routing.
Sorry, yeah, I don't quite understand the question. What can you
No,
repeat?
because basically, again, looking at this label stack,
Mhm.
it may be assumed that your SFFs are neighbors, immediate neighbors.
No,
But,
no need.
right, so basically between them, you can have MPLS tunnels that are locally, constructed based on IGP extensions for the
No,
segment
this-
routing. So actually, SFF labels being seeds advertised for IGP extensions.
Yeah, so we actually have two ideas on this one. The first one, we actually try to leverage some kind of a protocol to, so from SFF1 here to assign the label like a attached prefix somehow. And another one may be layer 2 function, because some function may be not fully layer 3. That one we kind of consider right now. So there's a certain method to assign the label for layer 3 function and the layer 2 function. Another one is kind of, we think that's probably a local behavior somehow. So we kind of still debate between the co-authors, which one will be better.
Okay, I just hope that you're not introducing a new protocol, but will use IGP extensions.
IGP, maybe BGP somehow, but there might be another internal implementation. It's
Right,
not
because
protocol.
Again, from Adrian presentation and your presentation, I see that there might be some good benefit of reusing IGP extension for the segment routing for SIDS.
Yeah.
At the close of this draft, I want to respond to your question. Let me try to understand your question. Your suggestion is we could use LSP directly instead of LDP tunnels between SFs, right?
Yeah.
Yeah, it could. In fact, we could directly use MPS SAM routing for searching, but to meet the transport independency requirement, which is listed in the SFC architecture draft, we'd better to support multiple underlays in our unified source routing mechanism, that is MPS over IP. The IP could be IPv4 or IPv6. In this case, it meets the transport independency requirement. In other words, you could use MPS SAM routing or MPS SAM routing over IP, okay?
Wim Hendricks, Nokia. I have a quick question on this one. This one is proposing a full proxy on the SFF to be able to perform this operation?
Yeah, kind of. Yeah, I mean, if you can have the ability to keep all the label stack, then remove it and add back, so the full as proxy function can be made on any router somehow.
You are not proposing to have the service function to look at the or to do a search until they have the NSH header?
Sorry.
So do you also propose in this solution to have the service function to be able to, let's say, I search until they have the NSH, so skip all the labels and just ignore them?
Yeah, that can be done because of based on the offset of packet. Somehow you can pass, if the service function can understand the offset somehow. Yeah.
Yeah, we'll close the line after Robert there, because we're a little bit out of time.
Do you have more slides, or are you done with the presentation? Okay. Can you go back a picture? That one, lovely. I'm slightly comparing this with the previous thing and trying to understand the role of the NSH in this figure. So I understand NSH as a metadata encoding. what happens in this scenario? What happens to the other fields in the NSH? Do they get updated as well? Do they have meaning? Does the SPI and SI in the NSH have meaning?
Basically, this can be discussed. Basically, we do not request the every hop to process NSH. That's a benefit of this proposal. Then, but on certain node, if the NSH can be understood by some virtual software router, OVS somehow, then they can be processed. But otherwise, we have no requirement to process the internal NSH either. That one is between the controller or whatever they negotiated the policy, which
Right.
node to change.
Right. So I'd be concerned then that you're moving around protocol fields that are defined as having meaning, but in your special case you're not using. That seems a bit risky, and maybe you want, if you have this picture, maybe you just want to replace NSH with metadata.
No, it's actually so the metadata is quite important to contain.
Yeah. I'm not saying don't have metadata.
Yeah.
I'm saying don't have all the other fields in the NSH that you're not using but have a defined meaning.
But that one maybe it requires a lot of change on the NSH part. We can
Don't change the NSH. I'm not saying change the NSH. I'm saying don't put NSH in, put metadata in. Just if you want to do this picture, just put the metadata in, because all the other NSH fields don't have meaning, and if you put them in, it's going to really cause confusion.
So we actually really want to leverage the
I think
NSH
we
all
need
the
to
works.
take this to the list. I have some comments and opinions, but they belong on the list.
Okay, sorry.
Robert Rashuk. So I'm watching these slides and also Adrian's slides, and it's great to actually, do SFC for, let's say, MPLS networks. But why are we actually always focusing on putting 5 labels in the data plane when you can achieve all the path steering with control plane? I mean, proposals are already deployed. L3PN with RT import-export or BGP vector routing achieves the path steering through the network pure in the control plane. And the packet can still have NSH header to pass it to a SF. So why of everything here, it's data plane centric, essentially?
It's actually also the controller plus this data plan part, but we actually try to define the path on the way. So that's the purpose for this draft. Okay, thank you.
Thank you.
There it is. Tal, John, can you take notes for this period since our secretary is presenting the material? And we don't have a lot of time, Tal.
Thanks. Okay, so my name is Tal Mizrahi. This draft is about an MD type 1 timestamp allocation. It's joint work with Ilan Yerushalmi, David Melman, and Rory Brown. And in a nutshell, the idea is that every packet that goes into the SFC domain is timestamped. Of course, there's an NSH, so the timestamp is attached to the NSH using an MD type 1 metadata. And then the timestamp is attached to the packet throughout the SFC domain. And obviously, when the packet reaches the egress node, the NSH is removed. So every SF or SFF can use that timestamp. Next, please. So what is the timestamp useful for? The draft has a few use cases, and we've discussed these in the past, so I'm only going to mention a couple of them. One obvious use case is to measure delay. So when the packet reaches the classifier, it adds a timestamp, T1. So then every other node, like an SF in this diagram, can receive the packet its time T2 and measure the one-way delay, assuming they're synchronized. Now, go back, please. Another possible use case is obviously for flow monitoring, like IPFix or SFlow. Can you still hear me? For things like IPFix or SFlow, and these already use timestamps in an SFC domain, it may be useful to have the timestamp relating to the ingress, to the classifier. So this is the timestamp allocation format. So one field we have here is the timestamp, obviously. It's 64 bits in the format of IEEE 1588 truncated format. There's also a source interface identifier and a sequence number, which can be used for detecting out-of-order delivery, detecting duplicates, and it can help in detecting loops. Next, please. So this draft has been around more or less since the beginning of the year, and why are we discussing this now? We've presented this in IETF 98. So a couple of months ago, the working group chairs made a call for MD type 1 documents. So one observation that needs to be made at this point is that, and it's general to MD type 1, MD type 1 is mandatory to implement. Another observation is that obviously MD type 1 is not as flexible as MD type 2. So MD type 2 has a type field. MD type 1 doesn't have a built-in type field. So that means that typically in an SFC domain, you'll only use a specific MD type 1 allocation. And having said that, we still believe there's a use case for more than one MD type 1 allocation. So for example, we believe there's a good use case for the data center allocation, which has an optional timestamp field, which is a 32-bit timestamp field. And we also believe there are use cases that may benefit from the allocation that we discussed here, which has a 64-bit timestamp. It has a higher resolution, higher granularity. And probably there may be other use cases for other allocations as well. So as the next steps, we'd like some more feedback, and we'd be happy to proceed to a call for working group adoption. Comments?
Yes, Greg Mirsky, CT. One thing, and I think that been talked, is that I suggest to allow support of NTP format as well, because though 1588 probably it's more advantage for the hardware timestamps. If you are in the software, then more likely that you are dealing with NTP, that NTP timestamp format will be your native timestamp format. But bigger question is, why not to use alternate marking methods? So, because I think that alternate marking method can help you. One of the problems and challenges of unidirectional measurements of time is that you require clock synchronization in your domain. So that's not the case, for example, when you're doing it on alternate marking method, you're doing on a node, for example, the residence time measurement, you don't need to have clock synchronization between your entities, because you are doing just residence time, which is a delay introduced by the node, right? It's your variable. So it's kind of, you're putting very strong requirement onto your network to have high quality of clock synchronization in order to produce useful and meaningful measurement.
So I would like to see alternate marking. I agree it's a good method, but measuring delay is just one of the use cases here. There are 3 or 4 other use cases which are not addressed by alternate marking.
That sounds like a good list discussion.
Yeah. And okay, regarding the NTP timestamp format, actually it's already in the draft. We haven't added it to the slides, but if you read the draft, it's already there.
Okay, I will. But I just want to mention, and probably for the group as well, is that alternate marking method can measure packet loss as well.
This is Linda Dunbar from Huawei. Just question, like speaking of the synchronization, well, this kind of timestamp measurement, are you intended for like adjacent nodes or is like across the network? Like, does that mean you have to have time synchronization for all the nodes to be able to make it accurate?
Well, we're talking about an SFC domain, so yeah, the idea is that when you use timestamps, you assume there's some kind of a synchronization mechanism between the SFC, at least classifiers, and possibly SFFs. Not necessarily, depends on how you use the timestamps. But yes, the assumption is that they're synchronized.
Also, because synchronization among all the nodes is very expensive, is there any other way, like options, you can do some kind of a rough measurement without synchronization? Like Greg mentioned, there's round trip delay or something.
Well, again, in the draft, there are 3 or 4 use cases. Some of them don't require synchronization. But I believe that if you are using a timestamp, that means you probably need the nodes to be synchronized.
Okay, thank you.
Thanks.
Let's go. Next.
Okay.
Hello. Hello. Good morning, everybody. I'm Devashish Purkayastha, and on behalf of all the listed authors, I am presenting this update to the draft. So in the last meeting, in this draft, we described the problem of service indirection in the context of SFC. So service indirection means dynamic and fast switching of service path between service functions. The SRR service function was introduced in the last meeting, which handles this dynamic indirection. And what this function includes, it decouples service consumers and service providers. A service consumer may be connected to multiple service providers through this SRR service function. And reclassification may not be required, and it switches the traffic flow to any service path based on this instantaneous situation and policy. Next slide, please. So in order to, in this draft, we go into some of the details of this SRR service function that was introduced. So to start with, we introduced the concept of HTTP-based transport within the context of SFC framework. Here, we described how URLs can be used as an addressing scheme, where we create service function path as shown with using the URL as the naming of the service functions. And this name-based relationship allows us, or basically we see them to be realized through replicated instances. So a service consumer now can be connected to multiple providers, and these are the replications that can use these different names. And then in turn, they are routed towards those specific instance is realized by this function. Now, bringing this notion of HTTP-based transport within the SFC architectural framework in terms of high-level operation, so the classifier function may now interact with this SRR to obtain what we call a service encapsulation. So we will get into the details about the service encapsulation in the next slide. So the classifier function may look into the network locator map and determines that the next service function is this URL, that is the name that is described there. And this information is provided to the SRR to obtain the next hop information. And then SRR returns the service encapsulation. Next slide, please. So here is the details of this SRR function, which is broken down into the different functions. The first function is the NAP at the ingress, which terminates the client-side layer 2 protocols. Similarly, there is a NAP at the egress, which terminates any transport protocol that is outgoing. And then one of the important function within this SRR is this called PCE, the path computation element. So this is responsible for selecting the correct next service function based on this policy enforcement. And any initial request from the classifier for a specific URL is sent to the PCE, and the PCE generates something called path identifier. And this path identifier is utilized for any future request for a given URL-based service function. And this is delivered to the ingress NAP. Next slide, please. So here we describe the function of this transport-derived SFF or TSFF. It is basically it is in the communication between ingress and egress NAPs, as well as NAPs to PCE, is realized through this transport-derived SFF. And this transport-derived SFF, there are three possibilities that are described here, which is basically, one is this SDN-based approach. It utilizes path-based forwarding using SDN-based wildcard matching fields. Now, it can also be realized via a beer overlay, which is the beer, which is basically discussed in the working group.
Just let me clarify something. Are you multicasting these packets? I didn't see multicast in the earlier stuff. Beer is a multicasting solution.
So if you remember, we when I started, I said that if there's a possibility that I can have this service producers, I can have multiple instances of the service producer, which can be connected to a single consumer. So in that case, I can use this beer multicasting mechanism. And then we utilize a flow aggregation approach, which is called edge switch classification. Next slide, please. So in terms, we see there some of the new protocol considerations that may be required. The first one is NAP to NAP protocol for HTTP-based messages that are exchanged between client and server NAPs. There's maybe a protocol for NAP to PCE for path computation and obtaining routing information. There may be a requirement for overlay transport protocol used for transport level exchange. Registration protocol used to register FQDN service endpoints. And I think the last, but not the least, the most important is content certificate distribution protocol to enable HTTPS support. Next slide, please. So yeah, so this is the last slide. Again, the intention is to collect feedback, and the use case that was described earlier and the details, whether looks reasonable or we are open to suggestions. And also just to make everybody aware, we are working on this solution in the H2020 Flame project with experience planned for early 2018 and beyond. So that's the end of the presentation. Any questions, please?
Hi, Kyle Rose, Sandvine. I read the draft last night, and I have to admit I didn't quite understand it, so maybe my questions are ridiculous. But you mentioned that we're using HTTP as a transport. I didn't see anything really specifying how HTTP was being used. Like when a traffic enters the system and it gets classified, do we tunnel it inside of HTTP? Is that what's going on?
I think those details are not described yet.
Well, I mean, like, do we do an HTTP put? HTTP is it's like an endpoint protocol. It's not really meant to carry traffic across a network.
Yeah. So basically, this is mostly using for name resolution. So using this HTTP URL, we are trying to identify in the service.
The URL isn't
endpoints.
HTTP; it's just a name.
Yeah. So using those naming, we're trying to identify the service endpoints.
Okay, so maybe we just take HTTP out of this entirely and just talk about DNS.
Your point is clear, but there's a lot of clarification needed in the behavior for the draft to even be able to be discussed by the working group.
Okay.
All right, maybe I have a bunch of feedback. Maybe I'll give it on.
Sure, if you can share your feedback, that would be great. We'll appreciate that. Okay, thank you very much.
Hi. So this is the last presentation before the lunch, so I'll try to make it fast to not, hold you back from your deserved lunch. So this is a common work with our colleagues from Interdigital. My name is Arthur Hecker. I'm actually presenting on behalf of Ramin, who is the first author but could not come. So this common work of Debashish, who just presented the slides, and Dirk and Akbar, and also Zoran and Ramin. So the point is here to somehow extend or discuss the notion of this SFFs, so transport derived SFFs, and somehow to try to use directly the transport networks, maybe without necessarily relying on the NSH header. Now, we do not have anything against the NSH header, and in some way this is similar to what has been discussed in the MPLS realm before, but let's say discuss this rather for the SDN transport. We notably have here a solution using the aggregated transport over SDN. I will explain why. And it also nicely combines with the SRR, which has just been presented before. Next slide, please.
Next slide.
Yeah. So in SDN, if you have, let's say, a huge environment using SFC or an SDN transport, the problems that you will run into will translate into the either number of rules installed and to be maintained in the SDN switches and SDN capable routers and all this network equipment, or you will need to somehow use a lot of encapsulation, tunneling, and so on, which will probably result in service-based overlays over the transport, which might not be latency and otherwise optimal, okay, respective to the service requirements. So because of that, essentially what we tried to do, we tried to produce an aggregated transport directly over SDN. So the advantage of SDN in this sense here is that you can, of course, have a completely different naming scheme, and that is what is being proposed, where essentially network at the end acts as a fabric, just interconnecting the edge nodes. So you have a minimum, the algorithm that is presented in a paper that we have written on that behalf in this regard, essentially achieves the following goal, giving that you have an attached number of devices to an SDN domain, let's say, the number of rules within the SDN network is minimum, okay? So this is an algorithm. I will not go in all details of that. You can read the paper. We can discuss it offline. It's not a problem. But the point is that we can have a special naming that is no big deal. We specially name the edge devices such that essentially we can aggregate them perfectly in the switches, such that the number of rules in the switches is minimum. Now what we do, we very simply misuse that, so to say, or abuse this mechanism to enable SFC. So what exactly we do is we essentially define the SFFs as being the edge nodes. So the idea behind that, or the driving, let's say, motivation behind that, is to say that an SFF may be some kind of ingress router to a, let's say, data center where many of those SFs can reside. And therefore, from the transport network point of view, an SFF would be somehow an edge node, okay? So essentially, we give an incoming request. We need to, route this incoming request, which has been classified, to the SFF, and from there on, the SFF will figure out which SFs are, responsible for that, and so on it goes. So this is the major idea behind that. Please, next slide. Yes, so here we use a hierarchical addressing in a way, and before Joel kills me for the ID chain here, I will explain how that works. So first of all, we have, of course, some SFF IDs, so we call it ID SFF, and then we have an ID for each SF, which is available within this SFF, okay? And this is being essentially assigned because we still here tried not to use the NSH header, again, not because we do not like it, but simply because, for example, OpenFlow cannot really use it right away, and the switches and the transport domain is independent of that. So we assign in the classifier that type of ID, kind of consisting of 3 distinct identifiers, and this is essentially chaining them through, first through the to the SFFs, and the SFF looks at the next byte or whatever is necessary in terms of lengths, depending on how many SFs are residing within one SFF, defines which is the SF, then it comes back, and so on it goes, right? And this ID chain information, if it's not available, the point is the following. If we have several chains starting, for example, in some service function SF1, if this exists, then we have in the transport network, we need to have different identifiers for that, such that we can distinguish them. So if this is not possible to have a specific ID for the chain as such, because maybe the architecture disagrees with that, then what we can do is we can define a fictitious node, well, let's say SF prime, which is, just another identifier for SF1 prime, sorry, and this would then just as well work. So there is an alternative addressing for that. Next slide, please. So this now just very simply explains more or less what I tried to explain, right? So once you classify it, you give this hierarchical addressing. Through this hierarchical addressing, now the transport network just used as a fabric can, of course, deliver the message to the SFF1 in this case. The SFF1 would then essentially deliver it looking at the next bit field to the right SF. The SF would always reply back, very simply, right? Where the SFF1 now would use essentially the mapping information as pre-installed by the transport pre-configuration. Again, we use a fabric. A fabric means that essentially all the edge nodes have already pre-configured passes. So we can skip maybe this slide and the next one, but just explain how it works. Yeah, next one. Next one. Yeah, this is this alternative addressing that I just explained. We can also speak that. Next slide. Okay, and that now integrates essentially with the SRR in the sense that SRR essentially proposes to resolve to use, let's say, identifiers coming from the DNS space or URLs, as you said. And these URLs can now be mapped, of course, to the IP addresses somehow, right? So essentially the chaining becomes some kind of chaining of, let's say, URLs, which need to be translated every time to IP addresses, and these IP addresses would need to be resolved somehow to map them to the layer 2 pass, right? And for this, we can essentially use exactly this SDN typical transport as Debashish explained before. Next slide, please. Yeah, I can skip this one because this essentially just explains that we can work with several domains. And now the pre-warming, so there is a latency, of course, for the very first request, because this is all in the transport domain. So when the very first request comes in and needs to be chained through, and so say the RSP has to become has to come into existence, right? What happens is that, of course, there is a communication with, for example, a PCE, or in an SDN-based transport, probably with the controller, which has to define the pass and find the pass through, all that. And this can be essentially shortened down by pre-warming. It means that those NAPs from the SRR drop before, they can essentially subscribe for this pre-warming service and very simply get all the possible chains that will, that are likely to go through them. That's the idea behind that. And then we have the next slide, which describes how it could be done, which kind of concludes my talk. Next slide, please. So the triggers for this pre-warming and what chains have to be pre-warmed where, that can be essentially derived from the orchestration, which means that from the allocation of the basic ID of the SFT chains, right? And then essentially it can get to the PCE to get these nodes. That's it. Next slide. Yes, so what we try to do here is to say that we can use the transport directly, so specifically not looking at the NSH headers, but again, we do not mind the NSH headers, exactly the opposite, we like them, but we just try to show that an SDN transport can be used effectively and efficiently to transport a lot of different chains. So right now, we did not yet address, this is the first submission. I think there is a lot of work necessary to advance this work if it's considered useful. But point is that I know that we can achieve dynamic SFC chaining with that, but we do not yet discuss it in the current draft. So any questions?
Hey, Kyle Rose, Sandvine. I had a question about the SFID and whether or not that concept supports a service function being visited multiple times in one chain. You talked about a virtual SFID, but I was thinking about it last night, but I don't quite follow my reasoning anymore, and it seemed like it might not. I was a little concerned about that.
In principle, it can work with any ID, because again, if you look exactly at what we did, we kind of concentrate on the transport domain only, which essentially ends at the SFF. Then it's a matter of SFF internal considerations. If SFF has thousands of different SFs and handles them in a specific way, it can use exactly this. The nice part of it is that you don't have to delve into this because it can be, relevant to whatever this SFF considers correct.
Okay, I think I need to reread the draft again.
Okay. We can also discuss it offline, no problem. So in principle, we only route to the SFF and provide some identifier from which we know that this SFF can, find out which SF is meant.
Okay, thank you.
Thanks a lot.
We have just under 20 minutes, so as per the request from our AD, we're going to present briefly and then encourage discussion of items for rechartering. Tal, this will probably be harder for you for minute taking, but is really important to track. So your chairs sat down with the AD and tried to put together a list of things we at least know people have been wanting to work on that seem to fit within the scope of what we think the working group is trying to do, that aren't work that belongs in other working groups and that sort of thing. So these 2 slides are my effort to capture that discussion. This is very, very preliminary, but in courtesy to the working group, we're sharing it anyway. Really, it's up to you guys what ends up in the charter. So with that, I'll try to walk quickly through the sets of bullets here. There's probably too many bullets for a charter even. We can't quite do everything all at once. It doesn't work. But these are all things we've seen interest in. So the top line item was Frank's proof of transit work. We know that A, he's been working on it, and B, the security reviews raised this issue repeatedly. How do you know that it's going to the right places? So this seems like something we need to do. In general, we saw a lot of time on OAM here. OAM is something we got to work on. Related to security, what can we do to talk about securing metadata when we need to? When we need to provide integrity protection, authentication, or confidentiality above just obscuring it by indirection. Indirection is very nice, but it's not powerful. So we have to look at what we need to do for that. We'd like to deal with the question of transport considerations. For example, how does the transport have to react to congestion? How does transports have to react to other common issues? When we tried to list what would we be talking about, we came up with an unfortunately long list of 4 different things that are all simple. These are just the simple cases. We know there are more. And this is why we're a little concerned about how to scope this work item. But we need to provide this guidance so that people can build transports that actually meet SFC's needs and can be deployed in operators' networks without breaking their networks. We really don't like to break operators' networks. Network management. Stuff has to be manageable. We've sort of implied, as you can see in the NSH draft, it talks about certain configuration information being provided. Whether you actually configure it with Yang or not, whether you actually configure it with netconf or restconf or something else, it is the common way for capturing. You need to be able to configure this information in the IETF. Other places one might use other ways, but that's how the IETF talks about it. So we need to do that. That's actually in the existing charter. So this is going to have to be in the new charter. There's ongoing control plane work. Adrian referred to the BESS work. There's also work going on in the PCE working group. We need to coordinate with that work to make sure it's doing what's needed. We're not going to undertake defining control protocols here. There are good working groups for doing that. Now, if somebody has I need a brand new protocol and I can prove that we really need it, we could have that discussion, but that's a pretty high bar to meet because there are working groups for doing control protocols. So what our focus there would be is integration with and coordination and validation with the ongoing control work in other places. One of the aspects of this that comes up is making sure we represent in the control operations ways to work with already deployed things that we know are doing service chaining. I mean, it's all well and good to say, here, do this brand new wonderful thing. Service chaining is not new. We're not under a pretense that we invented the underlying problem. Operators had the problem, vendors were solving the problem. So working out how the various control mechanisms, whether it's the Yang models or the control protocols, can represent the interworking with other mechanisms so that people can add this to their network and get working systems is probably important. The question of actually supporting, defining pre-existing mechanisms is a much harder problem. Don't want to get into that. Metadata, type codes for MD2, finishing the MD1 documents. These seem to be things people want. We just had a presentation on one of them. Where there is overlapping areas of concern, where other working groups are working on other solutions to service chaining, we need to coordinate with them. We need to talk with them, help make sure the problems address, that the solutions address the requirements. We don't get to tell other people, no, you can't work on things. We do get to say, these are important things you need to consider in working on such things. Other things that come up, there's the hierarchical work that David Dawson and Mohammed Bakadir and a number of other people have done. That seems to still fit within the scope. It's intra-domain. There are various ideas for how that should work. That would be a working group item. If people start actually deploying NSH, we'd love to be hearing about it, getting feedback on, whoops, this was a problem. This was wonderful. I love to hear that, of course. But we need to hear about actual deployments. And if we need to write a guideline on, having tried this, we found you need to keep these things in mind, maybe that's a useful thing we can produce. Real experience, real world is critical. May need some applicability documents. People keep wondering, how do you use this for 3GPP mobility? And it's very useful there. So maybe we need some applicability, and that's why maybe finish up the mobility use case draft. These are the things we came up with as ideas. Comments on this, positive, negative, additional, whatever.
This is Uma from Huawei. There are a
Swallow
lot
the
of
microphone, I'm having trouble hearing.
there are a lot of use cases where segment routing has to be deployed along with NSH. So there are two proposals like we presented, saw that, segment routing with MPLS data plane and NSH, segment routing with IPv6 data plane and NSH. These are the real deployment considerations where both are needed. So we might have to add explicit charter item where NSH and traffic engineering, some sort of traffic engineering, which is segment routing is one way of doing traffic engineering. So this kind of thing need to be included in the charter specifically to help the deployment use cases.
Kent Leong, I assume that for operational considerations, that would include the packet generation draft that we've been talking about, I guess, right? I know that you were mentioning about
That's an interesting question. I don't think that's operational. I think that's a separate item that we need to capture is the packet generation, packet returning problem that needs more attention. And yes, we have the draft, but we have to make sure that's within charter because it does need more attention.
Okay, I wasn't sure if it's part of that or not. So
I don't think it, I wouldn't try to pretend it was part of that bullet.
Okay, I might think it's a subset of that, but anyways, but as long as we could cover that, that'll be good. Thanks.
Since how to carry NSH over MPS is mentioned in the charter, I want to mention that due to the lack of protocol ID in MPS stack, whenever a new encapsulation such as NSH was proposed and it's happily had a requirement to be carried over MPS, some special treatment should be considered, especially the first niveau issue for the new handler.
Well,
I suggest whether we should allow the MPS to fix its own issue.
Clearly, MPLS, we don't take over their work, but if there are NSH specific issues, we need to identify them. That's part of what this bullet here on this slide is about.
Wim Hendricks, sorry, Nokia. I think the transport one is a very important one in my view, because we have been trying to do interoperability between multiple SFFs with different vendors. And today, because there is no real draft, it is hardly impossible to agree. You actually have to agree between the different vendors. And I think it would be very good to actually have some drafts, and maybe one transport protocol will not be sufficient, because you see clearly people moving, MPLS, there is a number of proposals, but most likely we also need something for data center with UDP or Geneve/VXLAN GP or something like that as well, because that's where you see most of the demand, at least from my perspective. So for me, the transport part is very important in my view, mainly for interoperability purposes, from my own experience.
Arthur Hecker, Huawei. So yes, I second that. I would say that indeed we should look into different transport, maybe going to some kind of BCP-like document which explains how different transport should be used with which encapsulations, not only for the NSH header per se, but also for the, for the content, for the chains, and probably with branching possibilities, with dynamic aspects. That would be, I think, because if you read it now, somehow it's missing. You can guess and maybe it's IP, or maybe it's something else, maybe it's L2TP. Yeah, maybe, but what is it?
Frank Brockner. So I have more of a general question. So all of this is useful, good stuff. So how do you prioritize? Should we go and do something like a Condorcet poll in the overall working group and understand where people are kind of congregating, so that we pick the topics that people both consider important and want to work on first, and then get, dates, timelines defined for those? Because I very much second the need that we go and recharter and get the new stuff in. But I just wonder whether we want to really take all of that on day one, or...
Yes, there is concern
some kind
about...
of a poll might be useful.
All of these things have constituents, but do we have enough people to do all of them? Do we have enough time to focus on all of them? It's a hard question.
Oh, this is Linda Dunbar. Question about this OEM mechanism. Are they in NSH header encapsulated, or it's just a random, like the standard OEM?
That we're not talking about transport OEM, we're talking about SFC OEM. Beyond that, the debate between the various IOAM encapsulations, Greg Mirsky's proposals on OAM headers, other people's proposals for OAM TLVs, that's for the working group to decide if we have the work item, and I sure hope we have the work item.
Okay.
The charter is not going to specify the solution. The charter is going to specify the problem.
If I have to give a vote, I think I will vote the control plan part for the SFC. I think that is very important.
And now our area director.
Atlas. Right. So the question is, we can recharter, do a lot of things. What do you need to get this stuff deployed? What do we need to have it be operationally useful in people's networks? And that's what needs to be in the charter. That's what you need and what you care about, so that you will be coming and doing the work rapidly to solve the real problems. I heard a lot of interest in the transport. I hear folks working on OAM. We've been working on OAM for 5 years. What are the operational, how do we get this piece done? There's the work on intra-domain hierarchical, is that let's keep augmenting, or is it something people operationally need, right? The working group has been stalled for a while, working on getting NSH done. It's done, okay? And now you can do the work that you passionately care about, that you need for deployments, and to have a complete solution. But to make that happen, it requires you say, yes, I want to do this, and put the time and energy into writing and reviewing the documents and getting stuff moving. I don't want to put stuff in the charter where there isn't that energy. So please think about it a lot.